Now see numericals on ILD. In previous lecture, we have seen ILD for support reaction, ILD for shear force, ILD for bending moment. How to draw ILD for reaction, shear force, and bending moment. Okay. When unit load 0. Similarly, when unit load is at point B, RB is equal to 1, RA is equal to 0. Okay. So here, in this type of numerical, only 3 types of questions in your ILD. Determine support reaction, then shear force, bending moment at point D. I already told you the section given in your question means what? Here is at point D, section is given. This is section. Okay. So at point D, we have to calculate shear force and bending moment. Okay. Before that, listen carefully, observe carefully. It is easy topic. Step number 1, draw ILD or calculate support reaction. There are 2 support reaction. First one is RA, here one RA, and second RB. So first we take RA, ILD for RA. In that, always assume when unit load is at point A, means unit load is at point A. Forget about this type of load. Okay. Unit load is at point A, RA is equal to 1, RB is equal to 0. We have seen already in previous lecture. Okay. When RA is equal to 1 and when RB is equal to 1. So draw this ILD first. This is baseline according to this. Okay. Now this is 1. Here is 0. Then join this. Now this is ILD of RA. Okay. After drawing the ILD, draw the coordinate of given load or use given figure. Means at this point, external force is given 20. So draw the coordinate line for this load. Then second one is 40. Then draw the coordinate line for this load. And this is UDL, starting point of UDL. So here is third coordinate. And this is already we know 0. Okay. Means what? After drawing the ILD for RA, for RB, shear force and bending moment, draw the coordinate for given load or external load. Okay. So after drawing the lines of coordinate y1, y2 and y3. Okay. How to calculate y1, y2 and y3? By using similar triangle. Now this is triangle. Okay. So by using similar triangle, 1 divided by 8 means what? Height divided by base. This is 1. Height divided by base. So base is 8. 2 plus 2 plus 2 plus 2. Okay. So 1 divided by 8 is equal to. Now this is another triangle. Y1. Again height. Y1 divided by base is starting from here. Base 6. So base is 6. Okay. After solving, then we get y1. For second coordinate y2, again similar triangle. 1 divided by 8 is equal to y2 divided by this. Y2 divided by this. This means 4. So y2 divided by 4, then we get y2. Again similar triangle. 1 divided by 8. Here is 3. Y3 divided by This is distance y3 divided by this distance 2. So then we get y3. Okay. All of you understand how to calculate coordinate height upon base, height upon base, height upon base by using similar triangle. Okay. I will tell you again. First, consider when unit load is at point A, RA is equal to 0, RB is equal to 0. Then draw 1 and this is baseline. Connect 1 to 0. Then draw the coordinate of external load. First, second, and starting point of UDL, end point of UDL. So this is Y1, Y2, Y3, and this is we know value 0. Okay. By using similar triangle, calculate all these values. After calculating all these values of coordinate, write down coordinate here y1, y2, and y3. Now this is complete ILD for RA. Oh, okay, you will get 1 mark here. Now second, magnitude of ILD, magnitude of RA means magnitude means what value RA is equal to how much the value of RA. So for getting value of RA, use this formula. Magnitude of RA is equal to simply load into coordinate 20 into 0.75, 40 into 0.5. Okay, see here where is 20 and where is 0.75. Now this is how to calculate magnitude of RA. 20 into this is first load and coordinate of this force is here 0.75. Okay, so 0.75, this is first term, plus second term, this is 40. So here is 40 into its coordinate, this is coordinate 0.5. Okay, this is second term, means what, load into coordinate. And now UDL. So there is some difference for point load and UDL. For solving this UDL, consider first intensity of UDL means what, 30. This is value. Okay, 30 into average of two values of coordinate means what, starting point and end point. Then coordinate of starting point is 0.25 and end is 0. So 0.25 plus 0 divided by 2. Okay, means what, 30 intensity of UDL into 0 plus 0.25 divided by 2. Okay, intensity of UDL into average of two coordinate. Where is this two coordinate? Starting point of UDL and end point of UDL. Starting is 0.25, end is 0 divided by 2. Okay, and whole multiplied by length of UDL. Length is 2. So length is 2. Okay, see here 30 intensity of UDL, 0.25 plus 0 divided by 2, average of two coordinates, starting point of UDL and end point of UDL, and whole multiplied by length of UDL. This is 2. Okay, now after solving this equation, we get 42.5. We get RE. Okay, similarly, now we are going to calculate ILD for RB. Again, when we draw ILD for RB, consider unit load is at point B. When unit load is at point B, then RB is equal to 1, RA is equal to 0. Then draw the ILD first. RA1 here is 0. Then joint the 2 points A and B. Okay. Again, draw the coordinate for external load. This is UDL this is 40 kilonewton load and this is 20 kilonewton load. Okay, after completing this diagram, calculate coordinate by using similar triangle. Again, this is y1, so 1 divided by 8 is equal to y1 divided by this base, means 6. Y1 is equal to, okay, again 1 divided by this 8, so this is y2 divided by 4. Okay, then again 1 divided by 8, y1 divided by this y3, sorry, y3 divided by, then we get y3. Again, magnitude of RB, this is complete ILD. After drawing the ILD, go to the magnitude, value of reaction, value of RB. Okay, so again there is a starting from point this. If we solve from point B, then first term is UDL, first load is UDL. So again intensity of UDL 30, okay, into average of 2 points starting and UDL. So starting here is 1 and end is 0.75. So 1 plus 0.75 divided by 2 and whole divided by length of UDL. Length is 2. Okay, see here 30, 1 plus 0.75 divided by 2 into length of UDL plus second term is, this one is 40. 40 into 0.5, this one is 0.5, and last 20 into this 25, then we get 77.5. Okay, there is no any chance to mistake. Okay, how to check if this answer is correct or wrong? Either it may be correct or wrong. Then use our usual procedure by taking equations of equilibrium. If we take moment at point A, okay, if we take moment at point A is equal to 0, how it is solved? 20 into 2, then 40 into 4, then 30 into 2 into 7 minus RB into 8. Therefore, RB is equal to, if by taking moment at point A, RB is equal to 77.5 and by using ILD it is also 77.5, then we have the correct answer. Okay, similarly after got the value of RB, take summation Fy is equal to 0, then we get Ra is equal to, if both value are matched with each other, then it is also correct. Okay, means there is no chance to cut the marks or to lose the marks. Okay. Now next is to calculate shear force. Okay, then how to calculate shear force? I told you already, to calculate shear force and bending moment, there is always given a section or a distance at which we have to calculate shear force and bending moment. In this question, shear force and bending moment asked at point D. Okay, so here is point D. Simply draw the baseline first. This is A point, B point. Then second step is to draw vertical line at section. This is section. So left part of section having negative shear force and right part of the section having positive shear force. This is A by L coordinate and this is B by L coordinate. Okay, so what is A and B? Left side of the section is A and right side of the section is B and total length is L. Okay, after calculating A by L and B by L, here is 0.5 and 0.5. Now again similar procedure, draw the coordinate for external load. So this is external load, draw this line, external load. Now this is end point of UDL, so this is UDL and this is UDL. Okay, so y1 here is y2 is 0. This is given 0.5. Again, for calculating these values, use this triangle. For y1, use this triangle. 0.5 height divided by base, 0.5 divided by 4 is equal to y1 divided by 2. This is 2. Y1 divided by 2. So we get 0.25. Again here, for calculating y2, use this triangle. 0.5. This is 0.5 divided by 4 is equal to y2 divided by this 2. Then again we get 0.25. Then write down the value here and here. Okay. Now this is complete ILD for shear force. Then again magnitude of shear force, simply load into coordinate, similar as R and RB. Load into coordinate. So load is 20 and coordinate is 0.25. 0.25. Again this is 40. Here is 0.5, 0.5, 40 into 0.5. Again there is a UDL. So 30 intensity of UDL. Then average of 2 points here is 0.25 and 0 divided by 2. Then length of UDL into 2 is equal to 22.5 kilonewton. Why there is a minus sign? Because this portion is below the baseline and having negative shear force. That's why here is minus sign. And this is above the baseline and having the positive shear force. That's why here is plus sign and here is also plus sign. Okay, remember always plus and minus. Below the base means minus, above the base means plus. Okay, in this way we got magnitude of shear force. Then again, last question, calculate bending moment at same point. Means again section is given, so draw the baseline first, mark the point where section is given and join this point with support. Okay, now coordinate at this point is AB upon L. We know that A means what? Left part section or right part means B. So A is equal to 4, B is equal to 4. Then we get AB upon L is equal to 2. Okay, means this triangle here is 2. Now this is 20 kilonewton on left part. So draw the coordinate. This is y1. Okay, then this is UDL point. Draw the line, and this UDL is no 0. Again y2. Okay, so here is y1, y2. Again by using similar triangle, this is triangle height divided by base. So 2 divided by 4, this is 4 distance, is equal to y1 divided by 2. Y1 divided by 2. Okay, then we get y1 is equal to 1. Again for this y2, 2 height divided by base, 2 divided by 4. Y2 divided by 2. So y2 is equal to again 1. Again, now this is write down, here is 1, here is 1. Okay, now this is complete ILD for bending moment. Then magnitude of bending moment. Again same procedure. Load into coordinate. 20 into y1. 40 into this coordinate 2. Now 20 into y1 is 1. 40 into 2. Again you 30 is intensity of UDL. Average between 2 points here. Here is 1. Here is 0. So 1 plus 0 divided by 2 into length of UDL. Length of UDL is 2 into 2. Okay, then we get bending moment 130 kilonewton meter. Those have difficulty, then see next numerical carefully. Same question are there. Okay. Shear determine support reaction, shear force, bending moment. Again, see here, section is given. Shear force and bending moment at point C. So this is C point. At point C, we have to calculate shear force and bending moment. Okay. Now again similar procedure. Draw ILD for RA. Now consider when we're going to draw ILD for RA, then unit load is at point A. So when unit load is at point A, RA is equal to 1, RB is equal to 0. Then draw the first baseline. Here is 1, here is 0. Then connect both points. Then draw the coordinate. This one is no 1. End point of UDL is here. Then 50 is here. Y2. Okay. So here is Y1. Here is point load. So again using similar triangle, 1 divided by base. Base is 10. 1 divided by 10 is equal to Y1 divided by this base. So Y1, this is 4. Y1 divided by 4. Then we get Y1 is equal to. Again for 1 divided by 10. Y2 divided by 2. Then Y2. Again magnitude of RA. Again there is a UDL. So intensity of UDL into average of 2 points. This one. So 1 plus 0.4 divided by 2 into length of UDL. Length is 6. So 6 plus point load 50 into 0.2. 50 into 0.2. Then we get 136 kilonewton. Okay. Now calculate RB. Again, when going to calculate or draw ILD for RB, then assume unit load is at point B. When unit load is at point B, RB is equal to 1, RA is equal to 0. So again draw baseline first. Then RB is equal to 1, RA is equal to 0. Then draw ILD. Okay. Now again this is for point load and this is for UDL. So by using similar triangle, 1 divided by base, 1 divided by 10. 1 divided by 10, y1 divided by this distance. So this is 8. Then we get y1. Okay. Now again 1 divided by base 10, y2 divided by this distance 6. So this is y2. Then again intensity of UDL 30. Then average of 2 points of UDL coordinate. So here is first point is 0 plus second point is 0.6 divided by 2. Okay. Into length of UDL, length of is 6. Then intensity of load 15 to 0.8 is here. Then we get RB. Okay. Now calculate shear force. So section given at point C means what? First draw the baseline. Draw vertical line at section. Left part of section is negative. Right part of section is positive. Then here I will show you in this figure. This is section line. This is a baseline. Left part is negative, right part is positive. Okay. So coordinate of UDL here is 0, and this one second coordinate of UDL. This one is A by L. Okay. Now this is B by L, and this is coordinate of point load Y1 or simply Y. Okay. Again this is 0. Means we have to calculate A by L, B by L, and Y1. So A means A to C, A distance. After putting all these values, A by L, B by L, and Y. For calculating Y, again use similar triangle. This one is height upon base. So 0.4 divided by 4, and here is y divided by this base. This is two distance, y is equal to. Now this is complete ILD for shear force. Always give the citation for figure. ILD for army. After completing the figure, give the name of figure. Means citation of figure. Okay. Now calculate magnitude of shear force. So here magnitude of shear force. Again, this is minus sign. So minus sign means what? This is in this portion there is a UDL. Okay. So this is below the baseline. That's why minus sign. Again intensity of UDL. Average of 2.0.6. Okay. See here. Here divided by 2 is missing. So 0. Here is 0.6 plus 0 divided by 2 into length of UDL is 6. Now this is 50 into this portion. 50 into 0.2. This is 50 into 0.2. Okay. 0.2. 50 into 0.2 is in plus portion. That's why we are taking here is plus sign. Okay. Here is plus sign. After calculating, then we get magnitude of shear force. Then bending moment. Again, given section at point C, draw the baseline, take mark point at point C, joint with support, draw the vertical line. Here is AB upon L. Okay. Again, there is a point load. So, for calculating height divided by base, 2.4 divided by base, and y divided by base. So, we get 1.2. Okay. Again, calculate magnitude of bending moment by using this formula. Then we get 276. So this is related to support reaction, ILD for support, ILD for shear force, ILD for bending moment. Okay. Hope all of you understand. If you difficulty, then ask me. Last 5 minutes remaining. Okay.